All right, Khalil, can you post this link to, are you guys smart enough to figure this out? I'm not sure. So that might have been insulting. Sorry. Khalil, can you post this link into the 10E WhatsApp chat? And then let's see if we don't get cut off for copyright violation. I can actually talk for a few minutes like we were hoping. Please. Hi, Lillian. Hi, Anne-Sophie. Hi, Panda Person. Panda Person. Hi, Bella. Who's Panda Person? Is that somebody from our class? I like pandas. Antonine. Okay, thank you. Manny's here. Hi, good morning, Manny. And hi, Antonin. Okay, we're getting pretty close. Where's Jofi now? Is he still on the other chat? There's Jofi. Hey, Aiden. Sky. Hey, let's go. Okay, we got enough people. I think it's worth getting to start here and have a short conversation, maybe do a little physics. So glad you're here. Glad you're hopefully sheltered safely at home, avoiding other people besides your family and all that stuff. Hi, Jonah. And I just wanted to kind of try this out because we might be in this mode for a long time, and we need to have ways of actually still learning. And I think that might be a tough transition for you guys. It's tough for the teachers as well, but it's important to realize that if this is going to go on for weeks or months, it switches pretty quickly from, oh yay, we got vacation, to, oh crap, we're going to have to do school this way, which is very difficult. So on the bright side, we're going to learn a lot about technology and how to actually do this over the internet. So I think there are positives there as well. It is Corona time, exactly. So we'll have to figure it out. This is my first content with whiteboard live stream with any class. So please be patient as we work out the kinks and figure things out, how to make things work. And please feel free to give feedback about quality of video, quality of the whiteboard, whether that works for you, and those kind of things. You can do that later. Maybe it would be a good idea. We only have about 10, 15 minutes left. I might go a little over, if that's okay. Hi, Severin. Because we don't have that much time together. So let's get started and just kind of remind you guys where we were in our class. In our class, we were just finishing up. Simple harmonic motion, a pendulum, and a mass on a spring. And in that context, it's now time to kind of take that idea and transfer it over to waves and talk about them a little bit. Now, you guys already talked about waves and math a little bit, but I want to make a physical connection for you guys. And specifically, I want you guys to think about an ocean wave, okay? And just imagine an ocean wave. So imagine you're standing by the seashore. You're looking out, trying to see the wave, and you see the wave, and there it is. And you see the wave as it presents itself to you. Now, by definition, what we have here effectively, as you look at this, is kind of a snapshot. What does that mean? So you've got kind of a camera, right? Here's a big camera. You're standing at the side of this thing. And I'll write camera here just to make clear what that is. And you've taken a picture of that wave. You've taken a picture of that wave and you're looking at it, and you've frozen that in time. What I mean by that is what you're looking at there, if you were now to graph this thing, And you would call maybe this 0 to get that nice kind of sine shape. If I go close, I think it focuses on me rather than on the board. So I'm going to see over there. The camera's not that great. Sorry about that. So if we take a look at this in terms of the position y, we'll get a nice graph like this. And you guys have done this in math, and you've said, oh, that's a sine wave, or you've looked at a cosine wave, and you've defined some quantities on this idea already before. So I'm just going to review that. The distance from peak to peak, same thing up here, that's actually the physical reality. Well, that's the wavelength, and we use generally the letter lambda for wavelength, lambda. Lambda. Wavelength, okay? And the other quantity that we can find on here is the amplitude here, and we generally call this A for amplitude. Okay, that's pretty much what we can look at there in this kind of frozen picture of what's happening to the wave. Now, we can also look at this wave in a different way. We can look at this wave from the perspective of a second person. We can look at this wave from a second person that's standing in the water. Good. And the red person that's not showing up too great. Let's see if we can maybe get that a little brighter. Does this marker work? Yeah, there we go. That works great. Okay, so we've got a second person in red. Okay, that person is also looking at this wave, but that person is going to look at the wave a little bit differently. That person's looking at the wave using a meter stick right there. Yeah, that shows up okay. And they also have a stopwatch. Okay. Now, technically, both people also need clipboards and those kind of things. But I want to have those two things here to give you an idea that this person is now looking at that meter stick that's sticking inside the water and watching as the wave travels towards him or her and measuring off how high the mark is on this meter stick as time passes. So as the wave comes in, like right now, it would be a low reading, and then it would go up, 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 and then top value, and then it would go down, 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 as a function of time, not as a function of space. So that's lambda, Bella. The letter here is lambda. It kind of looks like a dude kind of sticking one leg out and walking back with attitude. Lambda is the spelling, and that's for the wavelength. Okay. So I'm just going to read these things off because it is a little bit difficult to see. Down here says amplitude for the graph. That was the first person's picture. Amplitude is the height of the wave compared to the middle position. This is amplitude. And you guys did do this in math class. And this distance right here, the distance from peak to peak, that would be lambda, the wavelength. And it's spelled LA, I already said that, and the wavelength down here. This is for the black stick person. Then we have a red stick person over here. And the red stick person is taking measurements as a function of time with this very strange looking stopwatch here. So as the wave passes in, he will look where on this meter stick does the wave pass this. It'll go up and down. And if he records this as a function of time, then the graph would look something like this. This is the red person's graph. And this is again the height y, and we're plotting it versus the time t. Now in this case, we start low and then go high, right? So it would kind of look like this as the wave passes. Yeah, makes sense? As a function of time. And because it's, again, oscillating between the top and the bottom value, the red person should measure the same maximum displacement A, that same amplitude, as the black stick person. Okay? So this distance here, the amplitude, would be the same. Now, the reason I'm drawing this in red is, and this is the part you're going to get confused about, is that the distance here from peak to peak, this distance, you might be tempted to say that's the wavelength, lambda, but it's not. Well, why isn't it? Lambda was the wavelength, the distance from peak to peak. Now, this is not a distance because we're on a time graph. And stop posting in other languages like Arabic or whatever, and that's not cool. Thank you. So, or any stupid comments will be also not helpful. Okay, so this distance right here is not a distance. It's on a graph, so it looks like a distance, but it's on a time graph. So what that means is that this is a time from peak to peak. How long does it take for the wave to come and pass him? That is the period. That's not the same thing. Okay, so this is the period t from peak to peak down here, and period p. There we go. Period. That's the period. So we've got now important quantities defined, and we've got the amplitude a. We've got the the wavelength lambda, and the period t. And another thing that we hadn't thought about, which we should put on here, is the idea that, and I will post this live stream afterwards if you missed a part of it, then you can look at it later if you want to review it, and then you can also ask questions on there, and I can asynchronously answer questions. This wave is moving towards the guy standing in the water at a speed v. And that's a quantity that we haven't really seen on either one of these graphs. And it's important, though, to think about, because the idea of, well, how fast is the wave moving? That idea makes sense to the red stick person. It doesn't really make a sense to the black stick person, because the black person just takes an image in time, and that's it. But this wave is clearly passing our red person. So let's think about this together. How fast is the wave moving based on the three quantities that we have, A, lambda, and T? Okay, so the red stick person could measure and cannot measure the wavelength, because he's just recording the height and the position of the wave as it passes him as a function of time. So he does not have a measure of the wavelength. The black person takes a picture of the wave and then can, from that information, figure out how long the wave is. But this red guy is not measuring that. Okay, so let's think about this, and I want you to think about the wave kind of like a person walking, kind of like lambda walking. Okay, so if we think about this person walking, and lambda is like the wavelength, the step length. So we imagine an example. Let's say your step length is 1.2 meters. Okay, that's realistic. It's kind of long, but let's say you're a tall person and you're stepping about 1.2 meters per second. Oh, sorry, per step. 1.2 meters per step. And let's say that you're taking 2 steps per second, or the period between steps would be 0.5 seconds. So I just wanted to right away show something here. We said the period is 0.5 because I said we want to use this idea. Then that period is related to the frequency of the steps. T is how long it takes between steps. The frequency is how often you take steps. So if the period is 0.5 seconds, then the frequency would be 2 per second. We can express that by saying the frequency is the inverse of the period. Okay, that's an important little equation we should have in our toolbox to do some physics. Now, for our example, we're taking a step of 1.2 meters. Lambda is 1.2 meters down here is the wavelength we have. Okay, hard to see maybe. 1.2 meters is the wavelength, and your period is 0.5 seconds. So we take a step of 1.2 meters every half second. Well, how fast are we moving? Well, we know how to do speed. We know v, right, is distance divided by time. So in our case, the distance for this wave is lambda divided by period t. V is lambda divided by t. Good, thank you. And what that means is, well, for our example, we can say 1.2 meters divided by 0.5 seconds, we get 2.4 meters per second in this case. But pretty straightforward, I hope, to get. In the box between the graphs, it says F equals 1 divided by big T. The frequency is 1 divided by the period. And that's actually important here because if you look at this relationship, that's our second relationship that we got today. So F equals 1 over T, and V is lambda over T. Well, 1 over T is also frequency. Exactly, Khalil. Frequency is the inverse of period, which means that we can make a third relationship by replacing 1 over T with F, and V becomes F times lambda. Okay, there we go. And that's a really important relationship that lets us figure out how long, how wavelength, frequency, and velocity of a wave are related. The next thing we're going to do, not right now because we're going to be out of time very shortly. Our class normally goes till 37, so I'll take a few more minutes here maybe just to wrap up. But this relationship right here allows us to find, knowing the speed, if we know the wavelength, we could find the frequency. For example, for sound waves, for example, for light waves. Okay, so that's where that is. So I'm going to erase this now in just a second. Actually, no, I'm not going to do that. I'm going to leave it up, and then I'll take a close picture. It is Bella, but it's not, because our relationship down here was V equals lambda divided by T, and 1 over T is the same thing as frequency. So we can replace 1 over T with F, and it's basically taking the two equations and combining them into a new equation. I'm sorry the board is so small. It's kind of hard to show. Okay, good. All right. So I will not actually erase right now. Instead, I will take a picture of this that is a close-up, and I will send that to one of you that I know is in 10E. I'm sorry, all of you are in 10E, obviously. That is also an AP seminar. And then you please post this to WhatsApp, and I will also post this into the Google Classroom. Okay? So I hope that you were able to learn a little bit about waves, even though we had some technical problems, as well as having some startup issues. And obviously the screen is not that great, and my camera's not so good, and the lighting might not be so good either. But I'm trying, and hopefully we'll be able to do some of this. I haven't completely decided, and I'm open to input from you guys, how to mix this kind of a live stream instruction with YouTube videos of me or some other YouTube videos, textbook reading, and written assignments in order to make sure that you guys are still doing some learning. Okay? All right, good. So we're pretty much at the end, and if you want to provide some feedback regarding all the things I raised in terms of what we should be doing, quality of video, obviously the camera is pretty crappy. That's the webcam on my laptop, not very good. I might be able to get a better camera on Amazon or something. Would we ever try Zoom? Bella, that's a great idea. I have no idea. So send me some details about how that works and how it's better and all that stuff. I'm happy to try all kinds of things in order to make this work better. AP Seminar also has one at 10. I believe 10 o'clock was the time I scheduled. That's correct. Yes, 10 to 10:30 for AP Seminar. Yes. Okay. We should all do video chats so we can see each other. Maybe. I think bandwidth is an issue I think that I'm worried about. Also, I'm not sure if that's so great. Zoom is a live stream that cannot be recorded. Oh, okay. Well, this is recorded, and we need recording because I want you to have access asynchronously. Like a normal class, that would be cool, but we do have to record because I want to have you guys have access to it afterwards, or if somebody's ill, they can view it. You can mute us all. Okay, that's cool. I'm just talking about seeing and recording. Okay, but you can also raise your hand as a comment. I know. So maybe, but let's talk about it. We can figure out screen record. Okay. All right. Happy to talk about it. We are now actually at the closing time of our class. Just imagine the bell ringing in a 5 seconds, and hang in there. Have a good weekend. Nice seeing you guys, and I'll see you on Classroom.